Yaskawa.
The Technical Training Department of Yaskawa America Incorporated presents Setting Up a Z1000 Bypass. Hi, I'm Steve Kaler. Well, if you're planning to set up a Yaskawa Z1000 Bypass, we've got good news. The setup process is a quick and easy one for a qualified electrical professional to complete. And here's even better news. It's even quicker and easier if you prepare yourself in advance with the knowledge you'll need to do the job right. So let's begin with a quick overview of the whole process. We start by gathering together the proper safety equipment and tools. Then we'll adjust the bypass to suit the load. Next, we'll apply power to the inputs and make some measurements, adjust some parameters, and test the motor for proper rotation in both bypass and drive mode. We will finish the process by adjusting the system to make sure it's working correctly and your bypass is ready to go online and function successfully. If you start the setup process by gathering together all the tools you'll need, things will go smoother down the line. Be sure you have a set of standard flathead screwdrivers, both a small one and a large, plus a pair of wire strippers and a T-bar Allen wrench. You'll also need a digital multimeter, one that is able to accommodate voltage levels over 1000 volts DC and is rated for a minimum of Cat 3 measurements, but preferably Cat 4. Safety equipment is essential. We're dealing with high-power circuitry here, so you'll need a set of gloves, safety glasses, a cotton coat, and hearing protection. Lockout-tagout for a process like this is absolutely required, so you'll need lockout-tagout equipment. Last but not least, make sure you have a paper and pencil to write down some important information about your system. Before we begin, let's get the lay of the land by identifying the components in the bypass cabinet. The circuit breaker is referred to in the manual as CB1. The motor overload is identified as S10. The bypass contactor is K3. K1 powers the drive, and K2 connects the drive to the motor. The control power transformer supplies power to the logic components. The two donuts are current transformers, which measure the output current and bring the information back to the bypass control board. Z1000 bypasses come in a number of different sizes and configurations, but don't let that confuse you. The same components in the big units are also in the smaller ones. The only exception is K1, which is omitted in some systems. The physical position of components is a helpful thing to know, but the most reliable guide of component identification is the schematic of the bypass circuitry found in the Z1000 Bypass manual. We are almost ready to start setup, but before we do, we'll need to look at some nameplate information. We'll need to read the nameplates for our bypass, our drive, as well as for the motor that will be driven by our control. We'll look at the voltage rating for the bypass and the drive, then compare it to the voltage rating on the motor. We need to make sure that both the bypass and the drive are rated for the voltage that our motor requires. You'll want to write this information down for future reference and also write down the proper full load amp rating for the motor. You'll need the amp rating later. We also need to check the nameplate on the bypass to make sure the bypass is equipped with branch circuit protection. If the nameplate indicates that no protection is present, some form of branch circuit protection must be added before you can proceed with setup. Now, if you purchased a bypass that is equipped with a circuit breaker option, this need has already been met. The first step in setup is to adjust the circuit breaker to match the full load amp rating of the motor. And this is done by adjusting two dials on the circuit breaker with a small bladed screwdriver. Adjust the full load amp dial to match the rating of the motor. The other dial is an overload, and it should be set to Auto 1, the setting it received at the factory. Now we are ready to connect our line power. Start this process by making sure you have the proper gauge of wire for the current your bypass is rated to handle. Consult the Z1000 Bypass manual for detailed information on the proper wire gauges. From your main disconnect, wire up the circuit breaker and the ground lug. At this point, the system is still unpowered, which makes it a good time to address the system's safety interlocks. In normal operation, these interlocks are designed to prevent you from running the unit while powered when it's unsafe for your system to do so. To accomplish our setup procedure, we'll need to temporarily defeat the safety interlocks and allow the motors to run during the setup process. Now you have two options. Either attach a set of normally closed safety contacts here, or apply a set of jumpers. If you choose to apply jumpers, your technical manual will guide you to the terminals to use. When we're finished, it's very important to remove the jumpers before beginning normal bypass operation. Let's make some connections. Begin by attaching our motor leads to the motor overload. Then, connect the motor ground onto the ground lug of the Z1000 drive. After these connections are made, adjust the motor overload to the proper full load amps by turning the dial to the proper value indicated on the motor nameplate. Now you know why we had you write it down. Now we've come to the point where we can prepare to power up the drive and the bypass to run a function test. If the motor is attached to a fan or to some other mechanical system, make sure that the system is ready to safely operate during the test. Put on your safety equipment, remove the lockout-tagout protection, and power up the system. Take out your multimeter and set it to volts AC, and we'll take a measurement phase to phase at the top or input side of the circuit breaker. We'll take a set of test measurements from L1 to L2, L2 to L3, and L1 to L3, looking for balance. The readings should be the same within a tolerance of approximately 1%. If you would like to calculate your percent imbalance, here's the formula. In much the same way, we'll check phase to neutral, L1, L2, and L3 to ground. Of course, these measurements only apply to systems that have a true neutral. When the measurements are complete, we're ready to put the drive and bypass into operational mode. Close the door and secure it. Then activate the rotary switch on the front of the enclosure to close the circuit breaker. We're just about to check motor rotation. Begin by going through the Quick Set menu on the driver's digital operator and adjusting any parameters that need to be adjusted. Be sure that full load amps are adjusted to the full load amp capacity on your motor's nameplate. Now we're going to check motor rotation. If I hit the hand button on the keypad and then the off button, I should get the motor spinning for a moment, just long enough to see if it's turning in the proper direction. If the motor is rotating in the wrong direction, the solution is a simple one. Shut down power, lockout and tagout, making sure that you wait 5 minutes after lockout before going on to the next step, so you're sure that power in the drive's capacitor is discharged. Then open the enclosure. Check the DC bus on the drive at M+ and M- to make sure that the bus voltage is below 10 volts DC. You're now ready to switch connections T1 and T2 at the motor overload. That should reverse the motor's direction. After the leads are switched, close the door and power up the bypass. Perform the bumping procedure once again. Hand, then off. When you check now, the motor should be spinning in the proper direction. Now we're ready to safely test the motor all the way up to 60 Hz, the level it will operate at when it's in bypass mode. Start in drive mode and use the keypad to increase the speed by increments of 10 until we achieve a full 60 Hz. Once 60 Hz operation has been achieved, press the off key to stop the motor. We can begin our testing of the operation while in bypass mode by changing from drive to bypass, and this is done by pressing the F2 key. We can then bump the motor by pressing hand, then off fairly quickly, one right after the other. This will allow you to check the motor rotation. If the rotation isn't correct, switch connections L1 and L2 at the top of the circuit breaker. Remember to power down, lock out, and wait 5 minutes just as we did when we switched the motor output at T1 and T2. Perform the bumping procedure once again, hand, then off. And when you check it now, the motor should be spinning in the proper direction. Once the connections are switched, press the F2 key again to return the bypass to drive mode. Do a final bump to confirm that the motor is still rotating in the proper direction in drive. Don't forget to remove the jumpers from the drive and bypass before returning the system to normal operation. Once the jumpers have been removed, you're done. The bypass has been successfully set up and is ready for safety circuits to be attached in place of the jumpers we just removed. Well, we've come to the end of this training program, but it is definitely not the end of our commitment to make Yaskawa drives and motion products the best in the industry. The commitment to quality continues in the way we work with our customers and with our vendors. It's in the way we train our associates. It means we deliver product on time. We answer questions quickly, and we never say we can't. Yaskawa quality is reflected in the effort our associates bring to work every day. To us, quality means doing everything we can to make our customers, partners, and employees' experience a great one. We commit to that. We make it happen. We can because to us, it's personal.